Hello guys, welcome to my YouTube channel once again. Now we are going to discuss carbon and its compounds. So last time I told you people some basic things regarding this carbon and organic chemistry. Let's move forward. Let's take this carbon more forward. First thing, last time we were talking about this carbon. The first thing I told you people, that's the element of the periodic table. Element of the periodic table. And we discussed all that. Now, second thing regarding this carbon is derived from Latin word carbo, meaning coal. That means the second thing regarding the carbon is that this carbon is derived from Latin word carbo, meaning coal. That means the main constituent of the coal is carbon. That means this coal is totally, or I mean to say this is wholly or solely made up of carbon. Now, third point, this carbon is represented by symbol C. This carbon, third point regarding the carbon is that this carbon is represented by symbol C. Now the question arises, why we represent elements by their symbols? The only funda behind writing the symbols of the chemical elements is that it makes our study systematic and easy. That is, it becomes easy for we people to write and to remember. A third point regarding the carbon is that this carbon is represented by symbol C, a capital C. Now the question arises, why we represent chemical elements by their respective symbols. The only funda behind writing the symbols of the chemical elements is that it makes our study systematic and easy. That it becomes easy for us to remember and easy for us to write. Let's move forward. As far as atmosphere and Earth's crust is concerned, atmosphere and Earth's crust is concerned, atmosphere contains 0.02% carbon, rather 0.03% carbon in the form of carbon dioxide gas, and as far as Earth's crust is concerned, it is present in the amount of, or in the ratio of 0.02% rather. And being very meager in the nature, this carbon plays pivotal role, I can say immense role, important role in each and every aspect of our lives. For example, as far as we humans are concerned, there is 18.5% carbon present by mass. That means every single thing in this universe is comprising of carbon, and I told you people the importance of the carbon in yesterday's video lecture. Let's move forward. A fourth point regarding this carbon is that this carbon is a non-metal. Non-metals. We have discussed these non-metals in the previous chapter, metals and non-metals. I gave you the brief, I can say, description regarding these non-metals. Now, let me tell you some basic points regarding these non-metals. Let me capsulate certain things, important things. As far as our periodic table is concerned, as far as modern periodic table is concerned, presently we have 180 known elements. 180 known elements, and out of 180 known elements, some are metals, some are non-metals, and some are metalloids. I told you people these metals are electropositive in nature and these non-metals are electronegative in nature. And these metalloids are in between the metals and non-metals. Sometimes they behave as metals and sometimes they behave as non-metals. So, as far as our periodic table is concerned, our periodic table have been divided into certain blocks. Like at extreme left we have S block elements, and at extreme right we have P block elements, and in between P block and S block elements we have another block of elements that's called as D block elements. D block elements also called as transition elements. And beneath the periodic table there lie one more block of elements that's called as F block elements. F block elements, also called as lanthanide and actinide series. So as far as this carbon is concerned, I told you people this carbon is non-metal. Non-metal presently, as far as modern periodic classification of elements is concerned, presently we have 118 elements known, and out of 118 elements, some are metals and some are non-metals and some are metalloids, and they have been classified into different groups. Like we have different blocks rather. S block elements, at extreme left we have S block elements, and extreme right we have P block elements, and in between P block and S block elements there lie one more block of the element, that's D block elements, also called as transition elements, and beneath the periodic table there lie one more block of the element, that's F block elements, also called as rare earth elements. And we have discussed these things in the periodic classification of elements. I just gave you the brief description regarding these non-metals. So let's move forward. Electronic configuration. Electronic configuration, it's actually arrangement of electrons in different shells. I can say distribution of electrons. Simple. In simple words, I can say this simply the distribution of electrons in different shells. Atomic number of carbon is 6. First thing, let me clear you what atomic number is. Atomic number is actually number of protons or number of electrons. As far as protons are concerned, they have charge of 1.6 into 10 raised power minus 19 coulomb. And as far as electrons are concerned, they have a charge of minus 1.6 into 10 raised power minus 19 coulomb. So, as far as atomic number of, I can say carbon is concerned, carbon is having atomic number of 6. That means first shell, K shell contains 2 electrons, L shell contains 4 electrons. And according to the above principle, as far as energy distribution is concerned, its electronic configuration is 1s2, 2s2 and 2p2. The last electron, this is the last shell. So last shell contains 4 electrons, and the last electrons goes into the p subshell. That means this carbon belongs to p block elements. P block elements. This carbon belongs to p block elements. And these P block elements are mostly electronegative in nature. That's they are mostly non-metals. That's why this carbon is non-metallic in nature. One more thing. Let me quote one more thing. as far as this carbon is concerned, another method we have that's called as 10 electron rule. 10 electron rule. According to the 10 electron rule, if you have to are in a state to see the position of an element in the periodic table, you have to see the position of an element in the periodic table. According to the 10 electron rule, we have to add 10 electrons to the valence electrons, and that will actually show us the position of the element in the periodic table. For example, this is carbon. In first shell, it contains 2 electrons in K shell, and in L shell it contains 4 electrons, means this carbon contains 4 valence electrons. 4 valence electrons. Valence electrons are actually the electrons which are present in the last shell. That's called as outermost shell or valence shell. The more easiest way to see the position of an element in the periodic table, we have to add 10 electrons. According to 10 electron rule, we have to add as many as 10 electrons to the valence electrons. This will give us exact position of the chemical element in the periodic table. As far as carbon is concerned, it's having 4 valence electrons in last shell. That means we have to add more 10 electrons. That means 14th group. Means this carbon belongs to 14th group of elements. 14th group of elements. I think this is more clear to you now. Let's move forward. Now there's a test that's called as test for carbon. Test for carbon. I told you people that every single thing in this universe comprises of the carbon. Now the question arises, how will people will come to know that a particular substance or a particular thing contains carbon? For that we have to carry out a test that's called a special test that's called the test for carbon. For example, when a carbon and its compounds are burned in presence of oxygen, or by applying or by supplying heat to the carbon compounds, there is always the production of a carbon dioxide gas. That's effervescence of carbon dioxide gas. And whenever we pass this carbon dioxide gas through slaked line like this, this is CaOH2, is calcium hydroxide, also called as lime water or slaked lime. The moment we will burn the carbon and its compounds, the moment we will burn carbon means the thing which contains carbon, those are called as carbon compounds. The moment we will, burn these carbon compounds in presence of oxygen, because oxygen, it helps in burning. The moment we will burn these carbon compounds in presence of oxygen, there is always the effervescence of carbon dioxide gas, and whenever we pass this carbon dioxide gas through slaked line, there is always the production of a milky white PPT. Milky white PPT. That is PPT of CaCO3, that's calcium carbonate. This slaked lime is actually colorless in nature. Colorless, having earthy taste. Because earthy taste, why? Because this contains calcium. This calcium is alkaline earth metal. We have discussed this very thing in the metals and non-metals. That's why this calcium hydroxide is having earthy taste. The moment we will pass this carbon dioxide gas through this slaked lime, this carbon dioxide gas, the moment it will turn this carbon dioxide gas it will turn rather, bigger pardon, this carbon dioxide will turn this lacquered lime into CaCO2, calcium carbonate. That's actually chalk or limestone. The moment it will change the color of this calcium hydroxide, we will come to know that a substance contains carbon. So test for a carbon, let me recapitulate this thing. Test for the carbon, the moment we know that every single, I told you people in the previous lecture that every single thing in this universe comprises of the carbon. The moment we have to see that how we will come to know that this thing contains a carbon, for that we have to burn the carbon compound. The moment we will burn the carbon compound, there is always the production of a carbon dioxide gas. The moment, effervescence of a carbon dioxide gas, the moment we will pass this carbon dioxide gas through lacquered lime. Lacquered lime is colorless in nature. The moment we will pass this lacquered carbon dioxide gas through lacquered lime, the color of this lacquered lime will get changed into the milky, that's white PPT of calcium carbonate, also called chalk or limestone. The moment it will change it, we will come to know that a substance or a thing contains carbon. This was actually the test for the carbon. We will move forward in another lecture. So thank you for watching this and do subscribe my channel. Thank you so much.